Today I want to talk about the connecting rod. And the thing about the connecting rod is, well, you don't need to watch the whole video. Let me just get to it real quick. It doesn't make a whole lot of difference. But it doesn't mean there isn't some interesting stuff to watch. So, again, I've got to pop up my other camera, do a little bit of internet looking, and a little bit of math, and I got a spreadsheet and some numbers and whatnot. So, let's get to it. So here's a set of stock rods. Pretty straightforward. They're what's called an I-beam rod. They're about 5.4 inches center line to center line. You see this little divot at the back end over there? If you're going with a stroker crank, you can have those divots machined down. It's a good thing to do. Now, in the build that they did for the mileage motor, they used a rod similar to this, which is an H-beam rod. And let's see if we can look at what they said in the magazine. They used a 5.4 inch rod, which is basically stock length. They wanted to keep the torque range down low. Alright, this is one of those old wives' tales. The idea that you can somehow or another change the torque range by using rods that are available to us. And I'll get into it in just a little bit. There's a little bit of math that you can do. But you're stuck with 5 4s, 5 5s, and 5 6s, which isn't really much of a range. Isn't going to do anything. Let's go back to these guys right here. Alright, so anyway, they use these things, H-beams. And I think the idea was that these things might be a little bit lighter than stock. Doesn't make that big a difference. The other thing you can do is an H-beam or an I-beam. These are, of course, forged chromoly I-beams. They are considerably less expensive than those CB Performance ones. These happen to be from AA Performance and will be perfectly legit in getting the job done. Notice that they are kind of rounded in this area right there. They're probably a little bit lighter weight than stock, but not by much. They might be a bit of an upgrade. You can also get things like this from Scat. These are Scat rods. They're rounded back here in this area as well. You can look at this edge right here and you can see that it's a slightly different forging, so not everybody's getting their stuff from the exact same foundry. But the question you got to ask yourself is, everybody's got to have a position on I-beam versus H-beam. So, I'm an I-beam guy. H-beam, I think, is kind of stupid. It's a marketing gimmick. Now let me try and tell you why we consider them to be kind of a waste of time. Okay, these guys right here are a set of rods for a rather high-dollar vehicle. And, of course, they're old. This is an older high-dollar vehicle, but they were running I-beams just as the Volkswagen guys do. There's a little bit of you can see down in here that there's a little bit of metal taken out around this edge, so they are, without a doubt, they've got a bit more machining on them than our VW rods do. So, and as a high-dollar item, these happen to be from an old Ferrari. This is from a 1970s, 1980s vintage Ferrari. And as Ferrari continued on in their development, at some point in time they added additional horsepower. And they smoothed things out a little bit. This happens to be a slightly newer, slightly higher horsepower rod. It is still an I-beam. They continued adding torque and horsepower to their motors. This comes out of an even higher horsepower, higher torque motor. It is still an I-beam. This is a very high horsepower, very high torque beam that they have. I believe this runs on a turbo Ferrari. And sometimes these colors make it really hard to see. But anyway, it's really pretty rod. Also happens to be an I-beam. And this is from a newer Ferrari. This is not an old Ferrari. So you would think that these high-dollar machines, that if the way to go was an H-beam, they would have done it. They didn't. They all happen to be V8s, so maybe you're thinking, well, maybe there's something special about horizontals and those H-beams. So we jump over to these guys. Let's see if I can get them to show up somehow. Yeah, they look a little bit better like that. These happen to be ancient Porsche 356s. And in all the years intervening, we jump over to these. This is a, geez, how about, give me that back. Alright, this happens to be a Porsche Boxster. It's still horizontal, it's still a flat 4. It is still an I-beam. If there is a difference, notice that these things are very slender and they do not expand like ours do, so there is a little bit of a tweak to the castings that they've done. Okay, so this one right here happens to be a bent connecting rod. And notice, however, that the bending occurred across this way. So what does that tell you? Well, it tells you that there are bending forces on the rod. The H-beam guys will say there's no bending force. All you've got is an axial force going down, and there's no reason to do these I-beams. Don't listen to them. There are bending forces associated with these that are rather extreme that go in this direction. And those forces are associated with the movement of the piston and crank assembly as it goes back and forth and back and forth and back and forth. There are massive acceleration forces that get applied to the rods, which is why you put them in this I configuration. This thing would have turned into a pretzel if you'd had that same thing and an H-beam. And it would have done it at a lower speed and lower pressures. That happens to be from a motorcycle. So here are some interesting rods that you can perhaps dig around and find here and there. These are what are called Meckhart rods. They are extremely lightweight. Apparently they're rather powerful. Reducing mass, of course, is always a good thing. Cuts down on vibration, energy transfer losses, and such. So these were kind of neat. I stumbled across them while looking at some stuff probably a year ago, something like that. Just an interesting take. I'm not saying I do these, but they're an interesting take. And here's something that's a little bit crazy that you can actually do to your stock rods. And it happens to be this. This is what somebody posted over on the Samba. So they've taken this stock rod, and of course they've smoothed it down and taken all metals off over here. It's thinner up in this area. And of course then they drilled out the web. And the general consensus was, wow, that's going to actually blow up on them. They're not going to get any mileage at all out of this, but this actually runs, and it runs well for the person who built this. To say it again, no, you don't want that. This, yes, is what you want. You want I-beam rods. Don't waste your money. There's better places to put it. Now, if you got unlimited budget and you want to do it, knock your socks off. So we're back to another one of my spreadsheets, and this happens to be a spreadsheet that will tell you whether or not the change in rod length, I happen to have in here right now a 5.6 inch rod, will make any kind of a difference to your motor at all. Alright, if I put in a longer rod, it should make things change a little bit so that I can have a higher RPMs, or shorten it so that I can have more low RPM. Like those CB Performance guys, the guys who wrote the article was saying, we'll put a shorter rod in and we'll move our torque band. Alright, but there needs to be some physical definite changes in order for that to work. So anyway, I've built our motor. It's a 1745. Got the 76 stroke. Got 85. I've got a deck, which is what they used in the magazine. This is their combustion chamber. There's a certain number of cc's. This is the volume of a single cylinder. It gives them a compression ratio of 8.2 to 1, so my figures agree with what they did. And I'd like to be able to know at what point have I built my compression ratio up to within 10% of peak. And then of course you have to run into the actual numbers themselves and the formulas. You've got some crank positions. I've got a certain rod angle as the piston drops down, your rod angle builds, and then it goes back. So you've got a rod angle. It tells you where the rod is. It can tie all these numbers together and tell you where the piston is. I've got a certain amount of deck height. As you bring your piston up, of course the deck height's going to reduce. As you bring that up, your compression ratio is going to go up, eventually hit the 8.2 that they've got right there. I've got piston speeds, which are important, and I've got piston and accelerations, which are important. So what you want to do is you come back over here to this piece right here, and you put in 5.4, which is what they started with. And at 5.4, I get my 10%. Here, let me bounce up a little bit, just a sec. There we go. 7.4 is my compression ratio at 10% of peak. I hit the 10 point or the 7.4 I hit at 14 degrees before top dead center. So I've written that down, 14 degrees before top dead center. Let's make this 5.6. We'll just jump over to the largest one. That's the largest rod you can have. Notice that I still got 7.4 at exactly 14 degrees. So the longer rod, the general thesis is that a longer rod will allow your piston to dwell near top dead center for a longer period of time, allowing you more time to burn your gas, fuel air mixture. At a higher compression ratio, it'll burn faster. But as we can see, given the ranges of rod lengths that we have to play with, there's no difference. Near top dead center, there's absolutely no difference with this particular motor and the rod ranges that we've got available to us. So anyway, that takes care of the compression ratio. The other thing might be, well, how about our piston acceleration? If our piston is accelerating, well, this is going to cause vibration. Is notice that, let's see if I can zoom in on this a little bit. This would be the acceleration of the piston as it goes down the bore. This would be the piston as it's attempting to stop going down the bore. So you've got like a negative acceleration, and I've got a positive acceleration. And notice that the magnitudes of these are off by quite a bit, which is why your motor vibrates, and this is a second order vibration. Now, going back over here, let's just assume that I've put the numbers in, because I've already put the numbers in and I've pulled them out, and I don't want to go back over and do that stuff anymore. I just want to summarize over here. So we've got our two values. These are baselines. This is at the 5.4. I put a 5.5 inch rod in, and the accelerations change a little bit. The acceleration down dropped to 99.6% of it. I'm still within 1%, and I'm still within 1% on positive acceleration. Then we dropped it to 5.6 rod. I'm still within 1% on the down. I've gone to just over 1% difference on the deceleration. So the piston accelerations don't vary by very much. I mean, the idea is that a longer rod is going to allow you to have less vibration. This is the longest rod we can stuff in there for, given a typical budget, this is the longest rod that you could pop in there. In addition to that, you've got piston velocities. The guys will tell you, ooh, that short rod's going to have big piston velocity. Big piston velocity is going to give you a better suck. It's going to allow you to pull more power in. Well, again, we're mileage people. We don't care about power. We care about mileage. But let's look at their argument. All right, I've got a velocity. I've got a change in velocity. I've got another change in velocity. So as I run through my rods, my peak velocity has dropped by less than 1%. This is actually, what, 0.3%. So you haven't altered your piston velocity. Well, what about the location of the peak piston velocity? So we hit peak at 75. These two hit, this one's about 75.5. This one hits at about 76 degrees. So even these, the point at which you hit peak velocity has not changed. Now over here you get peak angle. So my peak angle with the short rod was 16.1. I've got 15.8. Here I've got 15.5. So there are some significant differences here, but what really matters isn't the change in the degree. What you want is the sign of the change in the degree. So that alters it slightly. And these numbers are ever so slightly bigger based on the sign of this particular angle. That's just a little geometry issue. I'm not going to tell you why, but it's important. But anyway, we do have a mild change. Now, what does this particular change impact? This impacts friction. So we've got a little bit of a change in friction. These accelerations would have something to do with vibration. And there's really not a huge change in vibration right here. Piston acceleration would have to do with how hard you pull your air at peak throttle. Whatever. And of course, compression ratio should involve energy out the tailpipe. So this is energy out the tailpipe. This is going to be vibration. So we haven't impacted that. We've only modified vibration by a teeny tiny bit. We haven't altered this, which may, to some extent, impact your power band, where you're going to be, but it hasn't. The only thing we really get is some change in friction. Doesn't mean the other effects aren't there, but this is the only one that's going to really make an impact. The problem with this is that even though this is nearly a 4% change, but it's only one piece of the puzzle, and there's so much other friction going on in the motor that, again, you're not really going to feel it. So there's no change in that. There's hardly any change in this, and even though there is a change in this, you're not going to feel it. So the bottom line is, it doesn't matter what rod you stick in there. They're all going to work. They're all going to be basically the same. So hopefully that little explanation has gotten you to the point that you realize that the stock rod used to keep the torque range down low. Alright? You could make that rod longer within the range of what's available to us. It doesn't matter. Just use whatever is going to make your engine go together the best. For instance, in the 2-liter that I'm going to work on, given that the B pistons are designed for 82 strokes and I've got a 78 stroke, I need a rod that's a little bit longer to make up for the fact that I don't have the stroke. So I'm going to pick up, when I redo my 2-liter, some 5.5 inch rods. But I'm not doing it in order to push up my power band or pull my power band down or anything like that. I'm doing it because it's going to make assembly of my motor easier. And that's really all that matters. You want to build the motor, whatever the rod makes the assembly easier, then use that particular rod. Anything else, and I hate to say it, I feel bad for CB Performance. I don't want to badmouth these guys, but this stuff right here, if you're forcing these things on a guy who's building a mileage motor, you've done them a disservice. They could have spent money on other stuff. Truly, there were other things they could have done with that motor than to plunk a pile of these things in here. What are these things anyway? Let me take a look here real quick. They're not horrible. This is about double the price of those other rods. So you could spend, these things, way back in the day, these things were like $1,000. They were $250 each. So, getting these things for $260 now, yeah, that's not terrible, but I still wouldn't do it. Well, hopefully that little rambling made some sense to you. There is genuinely nothing that's going to help you move your power band around, given the minimal range. I mean, seriously, the range of rod length change that you can do is approximately that much, and that includes, I think, like if you went into a like a Porsche 356 length rod, that's about it. I can make it a little bit shorter, so I can make it a little bit longer. You take all this stuff, and that's it, and it makes no difference. There's just it's not going to happen. It doesn't move your power band around. It doesn't alter friction. It doesn't help you to pin your piston up at the top dead center for a longer period of time so that you get a more efficient turn. What matters is that if you've got a stroked assembly and you got a B piston, but you didn't go with enough stroke to make the B piston work with what you've got, well, then you can stick a little bit bigger rod into it. Put a bigger rod in there, and your assembly gets easier. These rod lengths, they're about assembly ease. They're not about moving power band around. They're not about anything else that would come from this stuff. It's assembly. Just make it easy. Make it easy on yourself. Do the assembly. Do it cheap. It's just a rod, and it's a mild motor. It's not going to blow up and tear up on you. So just don't go crazy with the rod. Yeah, nice rant. I hope you liked it. Anyway, more later.